systems words problems. So we started talking about systems with a word problem about Nick, and he was making gourmet dog treats, and we had to find the break-even point in that particular system of equations. So we're going to take a look at some other word problems that don't necessarily involve a break-even point, but where we want to write two equations, or sometimes we want to write more, but in this case we'll want to write two equations using the same two variables. So we'll be looking for more than one variable. We'll need to define those variables. We'll need to write two equations to describe that word problem. And then we'll need to go through the 4 steps that we've been working with elimination. Unless anybody feels like graphing, you can always graph. But for right now, we're going to be using, not elimination, substitution. We'll be using substitution to help us find the solution for these in case they're weird, really big numbers or fractions or decimals. Just gets us straight to the point rather than graphing. So let's look at our first word problem. Tickets to a movie cost $7.25 for adults and $5.50 for students. A group of friends purchased 8 tickets for $52.75. Write a system of equations to find out how many adults and how many student tickets were purchased. So again, please remember that if you're looking at a word problem and you're stumped, go ahead and make yourself a T-chart. List out all the numbers on the left-hand side, then go on the right-hand side and list out what each of those represents. And when we're doing a system, see if you can kind of split those things into 2 different situations as they were. Then you'll want to define your variables and write your equation. So I'm not going to make a T-chart for this. I'm just going to kind of go through the word problem as it is. To define my variables, I usually start with, well, what's the question asking us? And the question is asking us how many adults and student tickets were purchased. So those are our 2 variables here. I'm going to use A to represent the number of adult tickets, and S to represent the number of student tickets. So those are my 2 variables. Then I'm going to go back and see what we're describing here. And we're really describing 2 different things. Some of this information describes kind of the cost of things. So I've got the cost of adult tickets, the cost of students' tickets, and the total cost. Notice we've got a total cost for these tickets. And remember, when we're writing an equation, if I have a total, typically that's going to go on one side of my equation. So one of my equations look like this. I've got a $52.75 on one side, and my other side is made up of all of the adult tickets plus all of the student tickets. So it's $7.25 times every adult ticket I buy plus $5.50 times every student ticket I buy. So this equation talks about the money that we're spending. The other piece of information is they tell us that I have 8 tickets altogether. So the other piece of information we talk about is how many tickets did they buy altogether. So I know that the adult tickets plus the student tickets need to add up to 8 tickets, which gives me kind of a limited amount of quantities that I could possibly use here. We're going to use our substitution to figure out the solution that works for this particular situation. So I have my 2 equations. So I'm going to use substitution here. So if you remember, our first step for substitution is to take one of the equations and solve for one of the variables. So I want to look for coefficients of 1 to make that really easy to isolate that variable. So the second equation is probably going to be the easiest one to work with here. So I decided to isolate the s. So I subtracted a from each side and got s equals 8 minus a. My second step, I'm going to take the second equation, which is this ginormous ugly one here, and I'm going to substitute this 8 minus a into that equation wherever I see the s. And I see it here next to the 550. So out comes the s and in goes the 8 minus a here. So from here I only have one variable. I just have my a. So now I just use my solving equation steps to get the a by itself. So here I use my distributive property. Next I combine like terms. I get 1.75a plus 44 equals 52.75. I'm going to subtract 44 from each side. Then I'm going to get the a by itself by dividing by 1.75. And I end up with a equals 5. So this tells me half of my problem here, half of my question, which was that they bought 5 adult tickets, which makes the rest of this pretty straightforward to do. But I'm going to follow through the steps anyway. The third step was to take this piece of information, which we already know, and plug it into one of the equations to find the other piece of information. So I know the adult tickets. I want to find the student tickets. They tell us the adult plus the student equals 8. So 5 plus s has to equals 8, which means the s equals 3. And the last part of this, for a word problem, we want to write our answer in English. So not an ordered pair for this because we're not talking numbers that I don't know what they mean. We need labels and units on each one. So they bought 5 adult tickets and they bought 3 student tickets. So again, using our substitution by writing equations and defining our variables from a word problem. All right, we're going to look at one more word problem, which is a little more generic, but it's still a word problem. 4 times one number added to another number is 36. 3 times the first number minus the other number is 20. we're going to find the two numbers. So when I'm done with this, I need to have two numbers. So I'm just going to use x and y. I'm going to use x as my first number and y as my second number. They kind of refer to them in there as that. So my first sentence, 4 times one number added to another number is 36. So 4x plus y equals 36. 3 times the first number, 3x, minus the other number, minus y, is 20, equals 20. So there are my two equations. So again, I'm going to go through those 4 steps. I haven't labeled them 1 through 4. You don't need to, but you want to think about those 4 steps as we use substitution. My first step, isolate one of the variables. I chose to use this first equation here because with one step I can get a positive y by itself. I could have used the second one, but I would have, since I have a negative 1 in front here, I would have had to do a couple more steps. So I used this first equation, I subtracted 4x, and I got y equals 36 minus 4x. So this 36 minus 4x is going to get substituted in place of the y in the second equation. So here's my other equation, 3x minus y equals 20. Here's the equation where I took out the y and replaced it with 3x minus 4x, 36 minus 4x. Don't forget our distributive here. I'm going to do minus 36. I'm going to do minus a negative 4x, so that's positive 4x. Next, I'm combining like terms. From here, I'm adding 36 to both sides. Then I'm dividing by 7, and I ended up with x equals 8. So my first number here is 8. So again, I've got half of my information. Now I'm going to take my x equals 8, and I'm going to substitute that into either one of the equations. I feel like I've been using the first one a lot, so I'm going to go with the second one on this one. 3x minus y equals 20. Remember from our graphing that the ordered pair, the two numbers I'm working with, work for both equations because it's where they meet. So if I know one of them, if I know one of the values, x or y, I should be able to plug it into either equation and get the same value for the second, my second number in this case. I'm looking for y. So it shouldn't matter which one you pick. Pick whichever one seems friendlier to you. So I use 3x minus y equals 20. I plug the 8 in where the x is. I got 24. I subtracted 24 from both sides. Don't forget that when I get rid of the 24, this leaves me with a negative y here. That negative stuck to the y. Remember, we can think of that like a negative 1y. So I have a negative y equals negative 4. I don't want negative y, so I'm going to multiply both sides by negative 1. That leaves me with y equals 4. So my two numbers are 8 and 4. And again, I can go back into my equations and check those, and those should work out just fine. So using the same steps of substituting, but again, looking at a word problem.